Hi, welcome back to the session. Uh, in the previous session, we discussed about how to set up the Kafka cluster in a Docker environment, how to set up the Kafka cluster with one node, one broker, and then one Keraft controller in the Kafka. So basically, we have not created any topics, we have not produced any data, we have not consumed any data, but we have just created some uh, the environment. So in Docker, it is up and running. If you go to Docker, Docker PS, it is up and running. The Kafka cluster is up and running, right? So go back. Now we will discuss about how to create a producer. Producer is used to produce data. Actually, producer is to produce data. So in this particular session, we will discuss about the producer configuration. So how to configure producer, what are various configuration options that we have got in order to produce messages. Uh, Probably we may look at basic topic configurations as well, but our focus is more on producer configurations. We produce some messages. We are not going to consume in this particular session, I hope. But subsequent sessions we will write about the we will do the configuration of the topics, and then we also uh, write consumers. There are so many things that we will have to discuss about it, but right now our focus is only on producer. Okay. So what and then how producer produces the message? Okay. Uh, so Kafka is kind of a distributed system. The meaning of distributed system already we discussed that it has got nodes. The nodes are actually some of them are brokers, precisely to store messages in partitions, to do the replication, and then to maintain the log files. But there is something else is called controller. Particularly Kafka metadata is managed by the controller, and then controller uses raft consensus algorithm. We call it as a kraft. Earlier previous versions of Kafka, people used to use the zookeeper, a separate component, to perform all these things, but now kraft mode is enabled in Kafka, so all the control related logic with respect to Kafka is managed by the controller. One thing that we should understand about Kafka, if you really look at Kafka, producer produce messages to uh, brokers, right? It depends on which broker it goes. It depends on the partitions. If we have partition 0, for example, and partition 0, 1, and then 2, I have similarly partition 0, 1, and 2. When the producer produces messages, it goes to various partitions. Okay, partition itself maintains its own log, actually its own transactions, right? So generally in a round robin fashion, messages are produced, messages are sent to the partitions, partition 0, partition 1, and partition 2. And produce consumers, if you look at consumers, I'm not going to discuss much about consumers. We will have a separate discussion on partitions and consumers. But for example, I have a consumer do not directly talk to the producer. Okay. Uh, Kafka design is not only completely distributed, but it is loosely coupled design. If you look at this Kafka architecture diagram, you know, if you have a look at the Kafka architecture diagram, this producer is producing messages to the topics. The topics maintain some partitions. Okay, topics are the topics that maintain partitions. So each partition maintains its own log. So partitions are always append only logs. You cannot the messages are always in the append only log. That means you cannot go back to any message and tamper the message that we already discussed. So the good thing about Kafka is there are so many patterns that we can do from producer to consumer. Producers produce the message, consumers consume the message. But one key thing that we have to discuss about this producer and consumer is consumers do not depend on producers and producers do not depend on consumers. Producers produce the message to the topics and consumers consume message from the topics, from the partitions which are associated with the topic. Those are there inside the broker. So there is no direct contact between producer and consumer. Okay. Producers still produce messages without consumers. Consumers can read messages if the messages are there, even without producers. Even producer means producer already produced some message, but producer is no longer valid, but still consumer can read those messages, consume those messages. So there is no direct interaction between producer and consumer. And then it is not a uh, directly pops up way of doing things, like producer cannot directly interact with the consumer. Even consumer doesn't know anything about the producer. Producer is aware of the topic, producer is aware of the broker, producer is aware of the partition, but producer is not aware of the consumer. Okay, consumer is not no need to be aware of the producer. And instead of zookeeper in our architecture, we were using Kraft mode. So Kraft controller is there. Kraft controller uses Raft conscientious algorithm. That Kraft conscientious algorithm ensure that all the metadata about the producer, partition, replication, topics are maintained, and then using the Kraft conscientious algorithm, all the nodes are managed and maintained. Right. All the messages are stored in a log file. All this log is append only log. Okay, each partition for each topic maintains a log that is append only log. Append only log means you cannot go back to the log and then you cannot tamper any message. Messages uh, it's kind of a ledger actually. You cannot go back and then tamper. Okay, like how there is a debit notes and credit notes, you cannot go back and tamper the credit. You have to write a debit note or a credit note once the amount is transaction happens. Similarly, in Kafka, you cannot go back and then tamper the data. That is not allowed in data. It's only append only mode, right? So coming to the producer, actually, just would like to discuss more about the producer. So what is required for the producer to produce message? The first one is producer needs some kind of a configuration. What is the broker a connection? What are the brokers? What is the broker or what are the brokers that the producer has to connect to? That is the first thing. What we call it as broker bootstrap servers. These are all actually bootstrapped servers. Generally, you can give any number of servers separated by comma, but we have only one server over here. So generally, we give localhost 9092. That is where our application is running on. Bootstrap servers, bootstrap.servers is the configuration that we have to give. So all the configurations are given in the key value pairs. We can also give serialization and serializer. There is also message serialization. Uh, Message serialization can be given by these particular uh, by these particular properties. Key serializer. So there are a couple of serializers. There is a string serializer available, which is these are generally Java properties. There is a string serializer. The message can be, you can give the property like this: key.serializer equal to apache.kafka.common serialization string serializer. Value serializer, uh, you can also give the value serializer as a string serializer, because the message has a key and the message has a value. We will see what is the importance of key and value later on, but I'm just showing you the uh, thing properties. There is a very, very important property which is called ACKS, acknowledgements. Actually, acknowledgements is called ACKS. So acknowledgement is not based on whether the consumer has consumed the message or not. The acknowledgements are based on whether the producer has produced the message, okay, or not. If it is produced successfully, and then has it been saved in the broker, that means in the partition or not, talks about the acknowledgement. So if you give acknowledgement option as 0, producer doesn't wait for the acknowledgement from the broker. Okay, the message may be inside the queue buffer. It may be stored. Sometimes there is a chance that the data may be lost. Let's say the producer is stopped even before it is written, then it doesn't get the acknowledgement, so it is lost. Second thing is, there is a leader. The brokers are there is a leader and follower brokers. You can also set up that, okay, just acknowledge to, let's, if the message is stored in the leader, then okay, I'm fine. The producer has successfully sent the message and the message has been received by the stored inside the broker. You can get as a leader. So leader and follower, generally message first goes to the leader and then from there it goes to, if there are any replication factor, it goes to different replicas. You want to have that kind of acknowledgement, you can give it as 1. There is something called all. All option talks about producer waits for the acknowledgement from all in sync replicas. That means there are 3 replicas that we want to store the particular message. If you give it as all, then it ensures that it gets the acknowledgement. Only all the messages are stored in all the replicas. Generally, for the highest availability and durability perspective, then it is good to give all for the production grade applications. But all brings some kind of a latency because it ensures that messages are always stored in all the replicas. But however, it is pretty good as well. For example, it tries to send the message to the broker. Producer produces the message and then push it to the broker. A broker means inside the broker there are partitions. It stores in the partition. If there are replicas configured, it store in multiple replicas. Uh, it it retries to store the message. How many retries you would like to do? Okay. Uh, like 5 retries. Number of retry attempts for failed send request if it's unable to send the message to the broker. I mean to say broker means broker, and then there is a topic and partition. There actually it's a log file. Ultimately the log file is created within the partition and then the topic and partition. Uh, okay, you can give retries. A retry is equal to 5, then you can go it with acknowledgement equal to all. If you work with acknowledgement all and then retries 5, then it retries for 5 times. It also ensure that it stores in all replicas. The other property is one of the very important configuration properties, enable idempotence. Idempotence ensure that the message is delivered exactly once. There are no duplicate messages. There is a concept called at least once, at most once, and exactly once. You can use this. Actually, we will discuss about that. You can use this for idempotence is true. The message is delivered only. No duplicate messages can be there. I cannot. No duplicate messages would not be there. And one more thing is, remember that multiple producers can also produce messages. Okay, it could be same message as well. Multiple producers can produce, because to a topic and for a partition, to a topic, when you talk about a topic could be split into multiple partitions for the horizontal scalability. For a topic, multiple producers can or may produce the same message. So the idempotence ensure that the message would not be duplicated. And uh, there are a couple of other properties that we can set it up with the acknowledgement, retries, and then idempotence. We will discuss about that. So idempotence is true or false value. Okay, it's a Boolean value. And the fifth one is compression. Compression techniques are very important. There are two things with the compression, and now you look at the compression. Number one, The size, actually, we talk about the compression. There are two things we need to discuss a lot about the compression. Sometimes it's one number one is how do you compress the data and then transfer the data? That means data transfer is very important. You want to transfer the data very fast to the sender. Here it is the receiver. The receiver is the uh, broker. uh, if it is compressed very well, okay, it's compressed to the most like ZZip compression is used, then the data is compressed uh, very efficiently. Okay. Efficient compression means there are two things again. The size of the compression is very important. If you use ZZip's compression, what happens? The data is compressed to the you know uh, possible smallest size. That means the size of the data is comparatively very small when you use gzip compression. But the other side of the compression, the flip side of the compression is then it has to, you know, decompress the data at the by the receiver. Here the receiver is what actually the broker is the receiver. It has to decompress the data. So if it compresses too much, then it takes a lot of CPU cycles or it takes a lot of time to decompress the data. So there should be some kind of a balance between compression and decompression. So if you use zzip compression generally compresses it very smallest size. It's pretty good in terms of sending the data, transferring the data from in the wire. But the problem is it compresses so much that when it has to decompress the data, it takes, quite little bit of extra time because it compresses so much, then it has to decompress. It takes again so much of time to decompress the data. There is some other thing is Snappy. There are all no compression or ZZip, Snappy, LZ4, ZSTD. There are four, five couple of compressions are there, but I'm talking about ZZip and Snappy, which are very regularly used. Snappy conversion means it doesn't compress so much. It is, I think, created by Google. It doesn't compress so much, but it compresses in a moderate way. But since there is a balance that has to be maintained between the compression as well as decompression, okay, returning data back once it is compressed, Snappy does the balance. So ZZip compresses very efficiently, but to decompress it takes a lot of time. So Snappy does compression and decompression. It does moderate compression, not as efficient as ZZip, but it does compression, maybe 30-40% bigger size than ZZip compression, but it is very efficient to, decompress the data. So it depends on ZZip gives takes data is transferred very fast, but to decompress it takes additional time. So there would be latency. Batching means you want to send the data in batches. What is the batch size? How many batch of messages you would like to send at a time for efficient IO writes and network writes. You can also send the data in batches. Okay, what is the size of the batch? Okay, uh, how much time to wait before sending each batch of message? Because it takes, if you give little time to send batch of messages, it can there is some time you're giving some time even to the broker, to receive the message. You are also giving some time to the publisher to send some messages. You are giving some time. So, but linger ms means time to wait for sending each batch of messages. Batch of messages means you are sending some messages, a bunch of messages to the broker. uh, how much time you want to wait before sending batch of messages? It talks about linger.ms. Okay. But the thing is that if you give some time, it wait for some time, so definitely it increases the latency of your application, but it improves the throughput. Because it improves the throughput means you are giving additional time, okay, for the batch to properly processed inside the data. So what is the memory that you would like to give for the messages that are unsent? It's pretty regular thing that producer produce the message, but it may not be sent to the broker. The broker may not receive the message. Okay, then what is the buffer size you would like to give? It's what actually a buffer memory. And then So how much time you would like to block actually if the buffer is full? So these things are very, very important when your application is sending plethora of data, it kept on sending data, your application is kept on sending data, uh, how much memory you would like to give to the buffer. 32 MB is pretty good number. How much time that you would like to give if it will block if the buffer is full. These numbers actually you have to adjust based on at what rate and then your messages are being sent and how big your messages are. Generally Kafka administrator and all they fine tune these messages. You have to use tools like Prometheus and etc. to see actually uh, how the rate of messages, how much buffer at a very peak time it requires, and based on that you have to fine tune the values. If the broker doesn't respond, okay, before the producer declared that it is failed after retrying for a couple of times. So what is the timeout seconds? Okay, timeout means it retries, but after some time it declared that it is failed. Then what we call it as a timeout. All these time related things are in milliseconds. Okay, so 1000 milliseconds is 1 second, so 30,000 is generally 30 seconds. So how much minimum time to attempt delivering a record? How much time you would like to give to deliver a record, attempting to deliver a record? That is also in milliseconds. 120,000 milliseconds is nothing but 2 minutes. You know that 6,600,000 milliseconds is 1 minute, and of course, uh, 120,000 is nothing but, sorry, 1.2 million seconds. 1,20,000 is nothing but 2 minutes. Record ordering is also very important. Per connection, actually, how many maximum number of unacknowledged requests per second? Acknowledgement you can give zero, or you can give one, or you can give all. Okay. If maximum number of unacknowledged requests per connection, how many unacknowledged requests you can have for the per second? Because the more unacknowledgements are there, then there is a chance of, that means it's not able to acknowledge, means there is a chance that the producer might have not sent the message to the broker, or the broker might have not even responded back. Maybe broker is very, very busy. So these numbers are also very, very important. Based on your setup, actually we set up the number. Security protocols, generally in a development environment we are using plain text, but you can also go for SSL, SASL. With SSL, we can give username, password, related things, and SSL certificates you can create, and then inside the cluster, you can create certificates, and then producer can have the certificate, even the consumer can have the certificate. Generally for the development purpose we are using the plain text. SASL mechanism is for the authentication related stuff. So what kind of SASL mechanism you are using? Right now we just make it as one of the examples is plain text and all. So additional settings, every client that we create as a producer, we can give an ID of the producer, so that the messages, uh, idempotence you want to implement exactly once delivery is idempotence, you can give it as true or false. Of course, true is called enabling the idempotence. Transaction ID means, for example, message goes to multiple partitions. You want to give each partition a separate transactional ID. It's not only the number but also transaction ID. You can also set up this transactional.id, transaction -1. You can give a transaction ID to the messages. And these are all the actually producer configuration options. We see one or two, and then later on we will dig deeper into, we change all this, we change all these messages. We change all these properties later on, and then see how does it work. Right now we are just going to produce. When you talk about delivery guarantees, this is very, very important thing, particularly whenever you talk about Kafka. Not only Kafka, any message broker. There are three kinds of deliveries. We have at most ones. At most ones means uh, if may be delivered, may not be delivered. Okay. Generally, if you look for pub sub, at most once means generally what happened. If not Kafka, if the consumer is not ready, the message is lost. But in Kafka, there is nothing related to consumer. If the message is produced, the producer produces a message, and then it is not stored in the broker. Okay, you put ACK's AS acknowledgements as 0, and then you don't put retry number, okay, maybe which is maybe 0 or 1 or 2. It retries to store the message once or twice, and you set up as no idempotency. You know that idempotency dot enable dot idempotency is false. Then it is considered as it can be depicted as at most once. At least once means at least once means the message is delivered to the broker, at least to the leader. Okay, that's the reason we put it as acknowledgements as 1. We don't care whether we don't care means from the properties perspective, we do not really worry about whether the message is stored in the replicas or not. The reason is the brokers and replicas, they work together because we are talking about the leader, then the follower generally follows. It ensures that the message is stored in other replicas as well. But there is a chance that once the message is stored in the leader, but by the time the message is being replicated, what if the leader fails? Then the leader fails, what happens? One of the nodes would become the leader. That is what the consensus algorithm is all about. Then in that case, there is a chance that the message is delivered at least once. Delivered means, remember that I'm not talking about the consumer. Delivered is with respect to the broker. Many of us think that PubSub based systems are delivery is different, but Kafka is different. Once we say that the message is delivered, we are talking about the message is delivered to the broker. If you give ACKS is 1, that it ensures that the message is delivered only to the leader. So you may miss the uh, high availability in the production grade system. What if exactly you send the message is stored in, because messages are kept on coming, stream of messages kept on coming to the broker. What if the leader itself is down? Then we are not ensuring any replication here by making ACKS equal to 1. What if it is not replicated? The message is lost as well. Okay, then the retries should be more than 0. Of course, low retries means maybe 0, but here you go for more than 0 retries, then it ensure it retries for few number of times, maybe 5 times, but it ensure that it is considered as it is stored, at least it is stored inside the leader. So we call it as at least once, because at least once the message is stored in the leader. Replicas maybe may not be, but at least in the leader it is stored. Okay. Generally, we give a retracer more than 0. Exactly once means at most once, at least once, ensure that once. Okay. Exactly once means what we do is we give all the acknowledgements as all. That means the messages are replicated in all the replicas. Then only we consider it as acknowledged, and we enable idempotence as true. When there is an idempotence, what happens? The message is stored only once. The messages, duplicate messages are avoided. So we have at most once, at least once, and exactly once. These concepts are there even in any other message broker like NATS and RabbitMQ, but the meanings are little different. Remember that at most once, we are talking about the producer to the broker. Broker in the sense I'm talking about the topic partition and replicas. Okay, but in pub sub model, we are talking about at most once, at least once, exactly once. We are talking from the consumer perspective, publisher and subscriber perspective. Here we are not talking about the subscriber or a consumer perspective. We are talking from the producer to the broker. Okay, so this is very important thing with respect to the Kafka. So retries is something which is very important. So ACKS is very important. Now, actually, they are acknowledgements, but okay, let's the property itself is ACKS. So zero means producer doesn't wait for the acknowledgement from the broker. So since it doesn't wait for the acknowledgement, what if the message is failed uh, to store in the broker? It's failed because there is no guarantee that the message will be stored. I'm not saying 100% it works very well, but there are chances. If you give one producer wait for the acknowledgement from the leader, only one broker, which is the leader broker. If you give at all, uh, producer wait for the acknowledgement from the all in sync replicas. All the replicas should acknowledge, then only it is considered as, yeah, the message is stored. All is, you can also give -1 value, but yeah, there is also, you can give as all makes more sense than giving a -1 value. This for the highest durability. Fine. This is what about the producer. Okay, there are some topic related things we will discuss about that. And whenever you create a message, you create a topic. We can now directly create a topic from the producer as well, but it is a that approach generally in the real-time Kafka environment. We seldom take that because generally Kafka topics are considered to be very big, and then administrators create the topics. The administrators create the topic, and based on whatever requirement or how many replicas you want, how many partitions you want, and all. These are the properties of the broker. You have to set up auto create topics enable. That means if the topic is not available, then do you want to create the topic? You can give true. Then if you set up this, then automatically whenever you create a new topic, if the topic is not available, brand new topic, it can be created even from the producer side. Number of partitions also can be done on the broker, not by the producer. Producer can only work on the partitions. Producer cannot create partitions. You can create a topic and later on you can increase the partition. We will see in the next session. A default replication factor, how many replicas for each topic there should be. There you can give the default number, maybe 2. That means at least 2 replicas are maintained. Like that you have to give the values in the broker. But however, we will discuss about this later on. Right. So let me create a simple broker in Golang. We are going to use Golang. So what I do is mkdir producer 2. I have another producer. So I created as producer 2, producer 2, go mod init demo, code main.go, package main, function main. Now I need to use the library. Confluent is providing the library. I can go to the internet. Confluent has given a library. This got to be the Confluent library. I take this library. I got the library. If I don't use it, it would be deleted. Either you have to use go get or you can use go mod tidy. I just put it as a blank identifier right now. Go mod tidy. This has to be downloaded from the internet. It got downloaded. Okay. Now I would like to create a producer. So now I have to create a producer. How do you create a producer? Kafka.new producer. You need to pass the configuration information. So you see that the pointer is passed over here. So I can give Kafka.config map, I guess config map, yes. Here, if you look at the config map, it's just a map with the key and value. Key and value, the value should be any value, key and value. Key is string and the value could be of anything. It could be you can give as true or false, or you can give a number. So actually, what is the first? We have to connect to the server. We call it as a bootstrap server. So this is the property bootstrap servers. Bootstrap servers. So I give bootstrap servers. Sorry, bootstrap servers. The port is 9092. Okay, this is going to give you a producer, and it also gives an error. If there is any error not equal to nil, I do it as panic error dot error. Now I have to produce the message. In order to produce a message, I need to have a topic. So I create a topic, maybe demo. Uh, I give it as my topic, user topic. I just create it as a user topic. For that, I create a new user. Okay, I create a new user. I give ID. I give name. I give email. Let it be very simple like this. Then what I do is I create a new user function, new user. I just give ID, name, email, and then I give a new user. So user ID is ID, name is name, email is email. So I'm going to create a new user over here. I have to return it. I have to return it. I returned it. Okay, right now, later on, we will add database and we do a lot of things. Now we have a topic, user topic and all. So what I do is the messages that we have to send, it's all based on actually the byte. So what I do, I create a user, 2 byte, byte or bytes, 2 bytes. I create a byte array and then create a message. So I can give JSON dot Marshall. So I give you, I get I marshal the data, which is the data is given in the JSON format. So let me give JSON data, JSON could be ID. Right now, I'm not giving any JSON data, but just tags I'm giving name. You have to know Go language for this. JSON email. So 2 bytes. This is going to be written as bytes. If u equal to nil, return nil comma errors dot new nil user. That's what I give. So I return as bytes. This is what I do. So now I have a topic. I have a producer. Sorry, I have to produce the message. We'll produce the message little later. Just for the uh, data, let me create a U1 is a new user ID. I give it as 101. It is in the U end because if you directly give values, it thinks that it is an integer. It has to be ID and name. Sorry, I can directly give uint of 101 Jitin P at outlook.com. These are the username, password, and stuff like that. U1 dot 2 bytes. I got to convert to bytes. I give bytes, comma, error, u1 dot 2 bytes. If error not equal to nil, that means it's unable to convert it to bytes. Then I say again panic. Right now I'm just panicking it, error dot error, because we are not sending so many messages. We are only we're trying to send only one message. This is how the message is sent. Okay, let me give this as a random number, rand.math, rand dot int n of maybe some number. I got a random number. Yeah, random number I'm generating, and then even if I run multiple times, it will create a random number and send the data. Fine. I have got bytes, I have a topic. Now I need to create the producer p dot produce. This got to produce the message. You see that there is something called Kafka message. So obviously I have to pass. There is also a channel. We don't need to use the channel. There is a two implementations. One, you can create the channel and then you receive the value from the channel. Uh, and then you, if the message is successfully delivered, you can use and then you can check whether the message is successfully delivered or not. That is one way. Other way is actually producer produce the events, then you can read the data directly from the event. So you can even neglect this, ignore this channel as well. So what I do first, message, let's produce message, Kafka dot message, and the event channel I'm giving it as nil. I have got an error. First of all, if error not equal to nil, that means fmt.println or log.println error. Fine. So the message, what the message contains, if you go to message property, there is a partition and the value is here. Actually, you have to send the actual message. Key, there is a different implementation. I will show you more about the consumers and stuff like that. In a final example, I will show a lot of patterns we will see. Just now we are only producing message. So let it be the just focus on value as of now. Key and all we will see later on. Key, topic partition and key. So topic partition is a separate type. So I go here, then I give topic partition equal to Kafka dot topic partition. What does it contain? It contains the topic and then it contains the partition. Let me go and then give the topic. Uh, Topic is address of topic because it expects a string array, string pointer, and then partition is Kafka dot partition any. That means any partition that is available, you can use that particular partition. That's what this. After that value, actually, this is the actual message that you got to send. It is called bytes. Okay, so you take this, so you have the message, you got the message, and write this. You can say log.println message has been successfully sent. There is something called flush, p dot flush. Flush is pretty tricky one. How much time do you want to wait for the outstanding messages to complete delivery? Okay, until it is timed out. Okay, uh, uh, so you always give the flush. You want to flush it actually. How much time you would like to give? This number is also tricky. Generally, in producers and all, you don't need to again very big number. Let me give it as 5,000 milliseconds. That means 5 seconds. It flushes. Flush and wait for outstanding messages because it takes little time for the message to be delivered in a really very big Kafka environment. Now, so all these things I'm doing, but there is one thing that the Kafka sends The producer gets the events. What these events? This event is actually a channel. So every time you publish a message, you produce a message, the message goes to Kafka broker, then I get an event. Okay, I can get an event. So what I do, E as range of events. Okay, so I run it as a go routine because it has to be executed continuously. So what this events does is I get a value called event. Event is Kafka.event. It's actually Kafka.event. It's actually an interface. You see, this is an interface which contains the string uh, of definition. So what I do is I get the value called E from the events channel. Whenever a message is produced, it comes as an event. So what I do over here is I wait event data E dot type. I use the type switch. You want to know more about Go language, please join my class. I explain very in detail of Go language. You become master in using channels and etc. Okay, uh, fine. So what if the message is case Kafka dot message? If it is a message, what we do, we get a result from EV. So if EV dot transaction topic partition dot error, if there is any error in the partition not equal to nil, okay, you can say fmt dot uh, log dot printf message is not delivered to the topic ID. You can give ev dot topic dot sorry partition ID, partition you can say. If there is no error, log dot println message successfully delivered to the following topic. You can give topic ID, same way ev dot topic partition to partition, following topic partition. You can give message successfully. So what exactly we are doing? We have connected Kafka. You can give multiple values. For example, ACKS. ACKS is all. I can give as all. Okay, that means all the acknowledgements you are giving. Like this, you can give a lot of properties. We'll see these things later on. But let's now focus on, because we have only uh, it's not print line, it's printf, right? So let's go and then produce the message on a topic, on a topic called user topic. So user is created, the data is converted to bytes. These bytes are sent as a value. So we have only one partition because by default only one partition is created. The partition is 0. You can also give topic partition as 0, but I would like to give it a value from the Kafka, which is called Kafka.partition any. Okay, any is gonna give you any partition. Internally, it is using a C library. That's the reason you could see that it is c.rd Kafka partition UA. Some constant value it is taking, some value it is taking from the C library. However, so once again, what we are doing, we take producer, new producer, we take a topic. If the topic is not there, it creates the topic. It's a property of the broker. If the topic is not there, you would like to create the topic by default or not. This is what auto create topics enable true. I give it as true. Then what I do here is I say go run. So message successfully delivered to the following topic partition 0. Message has been successfully sent. It was flushed. Okay. Actually, the topics are stored. My Docker container is storing the details here. So you can see that there is a user topic 0 has been created. Okay. Even though we cannot read the data, but you can understand that partition metadata topic ID. This is the topic ID that was automatically created, and you know you can open the log. Still, it is in some format. See, this is the data ID, name, email, and all. This is the data that got stored inside the log and all. If you send the once again run it, message has been successfully sent. Always the message is going only to the zeroth partition. You could see that. Uh, so you can go over here. You can go over here. Messages are stored 3 times actually to the same partition because we have got only one partition. Inside that particular partition, messages are stored. Okay. You can also increase the number of partitions to a topic. In fact, we can increase the number of partitions to a topic. Then, message may go to any partition. Okay, that also can be done. We can increase the number of partitions. Increasing number of partitions will what it does it help you to horizontally scale. The more number of partitions are can be stored on multiple brokers as well, so it is always good to increase the number of partitions if because parallelly they are processed. Okay, there is a pattern how the partition is attached to a consumer. In the next session we will discuss about how to send the same message by the producer to the partition that we can send. But we increase the partitions on a topic. Okay. Later on, we will also create a new broker, multiple brokers. Somebody also has asked me how to create a multiple brokers and also multiple care of controllers, a separate broker and a separate care of controller. That also we'll discuss later point of the time. But right now, how to create a producer. So produce a message. This is the message data you just value. There is also a key. Actually, key is very, very important. I will discuss about the key, why the key is very important, what is the offset, how the consumer can reread the data, what are consumer groups. These things we will discuss going forward. For now, actually, this is what about it. I'm pushing the code and the details to the GitHub location, git add, git commit. It gets added. I will put the uh, GitHub location in the video. Okay, thank you very much. Thank you very much. Bye.